Hi, my name is Afrina binti Najib from Sanyo. This is my lab reflection video for job sheet 6. Firstly, for the procedure, I use MATLAB Simulink with Simsky Electrical to do two different connection setup, which is delta star connection and also star delta connection. So for each configuration, required setting up AC sources, transformers, three-phase measurement tools, RMS blocks, and R-only resistor. So for the resistance used in both cases was based on the last 4 digits of my student ID, where my student ID is F54224029. So the resistor is 29,000 ohm. Meanwhile, for the materials and equipment, I use MATLAB software, where the tools or the component I use include power GUI, display, ground, demarcs, AC voltage source, series RLC branch, and three-phase transformer, three-phase VI measurement, and also RS measurement block. So what is the difference between delta star and also the star delta connection? In delta star, the generator is connected in a delta configuration and the load is connected in a star. Meanwhile, in star delta, the generator is connected in a star configuration and the load is connected in a delta. So based on my result for delta star connection, voltage at the load is reduced by square root 3 compared to the supply. Phase voltage is equal to 59.2 volt, where resulting power is quite low, which is equal to 0.121 watt. When unbalanced, the neutral point flowed, causing unequal currents, which is safer and more stable for light or balanced loads, but not powerful. Next, for my star delta, based on my result, is load is connected directly between two lines, so it gets full line voltage, which is 178.1 volt. Next, much higher current and higher power. Lastly, no ground or neutral, where we can measure phase to ground, which is ideal for industrial or heavy load application. Next, we move on to balanced and unbalanced three-phase. In the balanced setup, all three loads had the same resistance value, which is 29k ohms, based on my student ID just now. So based on my result, the phase voltage I got were around 59.2 volt across all three phases. The currents will also equal around 2.042 to 2.047 milliampere. The power for each phase came out to 0.121 watts, consistent across all three. So this shows a perfectly balanced system, meaning the voltage, currents, and also power in all phases are identical at 120 degree apart. To stimulate an unbalanced load, another 29k ohm resistor in series with phase B. So this increased the total resistance in that one phase. So based on my result for this unbalanced three phase A current stayed around 2.047 milliampere and phase C was also stable. But for phase B, currents dropped to 1.019 milliampere, almost half. So power in phase B also dropped to 0.060 watts, while phases A and C remain at 0.121 watts. So this clearly shows that in an unbalanced system, the phases no longer behave equally. One of them ends up carrying less current and also power. All in all, for this lab report, I found that delta star gives lower voltage and power, which is suitable for light loads. Meanwhile, for star delta provides higher voltage and power, which is ideal for heavy-duty application. So in a balanced system, all phases share equal current and power. In an unbalanced system, one phase draws less current and power, causing instability. So one of the challenges I faced was trying to search for components in MATLAB, since there is too much category to find the exact specific component. So that's all for me. Thank you.